All right, everybody, this is 1.2c, and we're talking about range and domain today, which are two attributes of functions, ways that we describe graphs of functions in particular. And so that's the only two things in this video, and they're basically, again, ways to describe graphs and really share information about where the graph stops and starts and what values it includes. So I've got two definitions. One example we'll do, and then a couple examples on the back to get you used to this terminology. So we're going to start with domain. The domain of a function, so I'm going to actually outline it in pink so we remember this is our pink for the day. The domain of a function is the set of inputs for which the function is defined. So the set of inputs for which the function is defined. If that sounds like gibberish to you, really what it's saying is it's the set of possible x values. It's our set of possible x values. What x values can exist in this graph? What is the graph covering? And so I'll start by just showing you where the domain is on here. Domain talks about this axis, our x-axis, and our goal is to figure out for which x values does this graph have a point for, right? If we look at the point 10, you can kind of tell that no matter where I go, I'm never going to find a point where this graph has a value where x equals 10. The graph stops here. It doesn't go on this side. So 10 is not an x we can put into this function. It doesn't give us an output. There isn't a rule that would tell us what happens if we put 10 in. So to find our domain, we actually look at the graph and we try to identify where on the graph we start having values. And I see it as right here. That at the beginning of this graph, this is the point on our x-axis where we start to see a relationship between x and y. We have a line. And my domain keeps going, and I can imagine that this goes on forever. If it's not telling us it stops, we always imagine it goes on forever. So this set down here is what we call our domain, and we want to define it as a range of x's. So I'm going to look back at my point where it starts. This is the point -5, 4. So what that tells me is my earliest x value, the first x value I can use is x equals -5. And so I know that it's somehow related to -5. And that's my first one, and all the other x values are bigger than it, right? We're moving to the right. So really, my domain is anything bigger than -5. Anything bigger or equal to -5. Oop, you couldn't see me there, sorry. So by domain, how we write it is x is greater than or equal to -5. Lovely. All right, the range of a function, as you can probably guess, has to do with our y values. So I'll do this one in green. So the range is the set of all possible outputs. The set of all possible outputs, which in other words is the set of possible y values. The set of possible y values. And so just like with domain, I do this graphically, and I look at my graph, and I'm going to start at the top and say, okay, none of these points have a line yet, right? I don't see any graph up here. My very first point that I reach is this one again. So I'm just going to pull it over here to make it easy to see. This is probably going to be this y value, the start of my range. And anything below this counts. You might think, well, how do we know this goes down forever? We don't really know 100% of the time, but because the shape of this graph looks like a square root graph a little bit, we can guess that this goes on forever, unless it's really obvious that it stops. So this here is my range, and I write it in relation to our y values. So in this case, this is my highest y value, and everything else is less than it. So I'm going to say y has to be less than or equal to, and what is the y value of this point? It's 4. Right, we're 4 up on our axis. So y is less than or equal to 4 is our range. So our domain is x is greater than or equal to -5, and our range is less than or equal to 4. Any other numbers that don't fit in this range and domain don't have a relationship for x and y. We can't actually use this function to tell us anything. We're going to do a couple more. I'll stick with the same colors, just 2 more here. These are 2 functions, and I've showed you the graphs of them, but you don't need to see them for now. We're going to start with our domain. Remember, domain is our x left to right. So this is the function. I should make this function notation. It says y equals, but really it's f of x equals x plus 2 squared minus 4. And I'll change this one while I'm at it. So here's my graph, and I want to look and say, okay, I know it's a parabola. And so is there anywhere on my graph, and if I think about a parabola, where I can't plug in an x value? And actually, I know that these go on forever and eventually reach all my values, right? They don't stop anywhere and say, nope, you can't go further. So this is a nice graph because really any of these values counts in our domain. There's no obvious place where this graph stops or reaches an endpoint or gets cut off. And so our domain, we would say, are all real numbers. Our domain is that x could be all real numbers. That's nice and easy. Our range, however, is a little different. If I'm looking at my graph, I see that there's function up here, there's a line, there's a relationship, but as soon as I get to this point, below it, there's no longer a graph or a relationship that I can see, and I know this graph doesn't come curve around back somewhere else. So this is where my range begins, and my range is everything above it. That's all where I can see a line, where I can see a graph. This is the point -2, -4. So I know this point is at -4 is y. So my range is going to be that y is greater than or equal to -4. It starts at -4 and it goes up forever. All right, last example. This one here is range and domain again. We've got our graph. I'll take my domain. I can see a function here. I'm looking, and I stop. This is the farthest point on my graph. And I know that my domain's going to come this way. And so I can see that this point, it looks like the point 4, 2. And so my domain is going to be that x is less than or equal to 4. And my range, if I go down here, I can also see that this is the point where it starts, and there's no function down here at the bottom. I don't have a line. So my range will be y is greater than or equal to 2. All right, that's it. We do this graphically. Just be careful not to get them confused. One tip that I'll give you if you want to go back to the first page of your notes is that some people find it hard to remember which one is range and which one is domain. And the tip that I hear a lot of people use is this one. They draw a little axis and they imagine a stupid little house on the y-axis, which only works because it's weird to have a house on the y-axis. And the way people think about it is they say home on the range. You know, that like silly song from childhood, home, home on the range, blah, 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 blah. And so if you think of that song, you can think, okay, I've got this stupid picture of a home on the y-axis. And so it helps you remember your range is y. And if range is y, then domain must be x. Stupid trick. Hopefully it helps. All right. Have a nice night, guys.